Hello learners, welcome to this session. This session is 10th session in its series. Course code is MCS 221, Data Warehousing and Data Mining. And then today's topic is OLAP and Data Warehousing. So this particular OLAP, the full form is Online Analytical Processing. And this is a technology for performing multi-dimensional analysis at high speeds on large volumes of data from a data warehouse or a data mart or some other unified centralized data store. So this particular technology is an interface between the front end and the data warehouse. So this particular layers in earlier stages, most probably there wasn't this particular layer of OLAP. However, in present data warehousing applications, we find this particular technology as an essential component. This OLAP organizes data in the form of multidimensional cubes. So this is the data structure that the OLAP will be using in order to make the queries very faster. So otherwise it will take hell of time when we directly put the query on relational databases. But when it is existing in the data warehouse and without OLAP, most probably even then the time will be high. Otherwise, with the use of this particular technology, the queries will be very much efficient and will be retrieved very much faster. So the data structure you have to underline here is the multidimensional cube data structure. So most of the businesses data will be having several dimensions. When we take the case of the relational database management system and put the queries pertaining to the data warehouse or else mining queries to extract the interesting patterns, it will be very much difficult because this particular data, whenever we put it in the data warehouse, we will be following certain characteristic features. As we had learned from the earlier sessions, the first characteristic feature is the subject orientation. So all the data will be like stored in the with respect to a subject, and then the data is non-volatile, time variant. So these are certain essential characteristics that a data warehouse possesses. So here the business, whatever the query that we wish to put upon, will be having several dimensions. So the most prominent dimension that we had talked about is the time dimension. Each and every dimension with each and every data will be speaking with respect to the time. Either it may be yearly data, either it may be half yearly data, quarterly data, weekly data, whatever the case may be. The prominent dimension that we were talking about is the time dimension. For example, you can see the sales figures might have several dimensions related to location, related to time, product, or many more. So this is the sales. Suppose if you want to calculate a simple sales figure, the query can be placed with respect to the location, that is one dimension, or else with respect to the time, or else with respect to a product, or else with respect to a salesperson, with respect to a store, or else with respect to a continent, whatever the case may be. So all these dimensions comes into picture whenever we wish to extract the meaningful patterns by using the data mining tools. So in a data warehouse, data sets are stored in tables, each of which can organize data into two of these dimensions at a time. In the earlier example as we had seen. So most probably two dimensions will cater to a one particular table, other two dimensions may be to the other table. At most, we will be considering three dimensions at a go. So this OLAP extracts data from multiple relational data sets and reorganizes into a multidimensional format that enables very fast processing and very insightful analysis. These particular queries can also put directly onto the data warehouse, but it will be taking much more time. with the introduction of this particular OLAP technology, the time will be minimized because all the aggregate things are being stored in the form of OLAP cubes. So let us see the characteristics of the OLAP. The first characteristic is the fast. So OLAP, it is nothing but it is an interface between the data warehouse and the front-end tool. That is the data mining tool that you are going to use from the user's side. So it is just lying in between the data warehouse on the other side and the front-end tool on the second side. Hence, it will be helping us in better accessibility of data, yielding the faster results. How complex the query may be, if at all you are using the OLAP technology, beforehand the whole things will be structured in the dimensional cubes, and from that particular cubes directly we can extract the data. That too, there are several operations which we are going to talk about in few minutes. The second characteristic that we can talk about is the analysis characteristic. So OLAP data analysis and then measure and the results are stored as separate files. So it distinguishes between 0 and missing values. It should ignore missing values. OLAP facilitates interactive query handling and complex analysis for the users. So this is the analysis part is the second characteristic. And then the third characteristics is the shared characteristics. These particular OLAP operations may be drill down, rollback, pivot, or else slice, dice. These are the operations which we are going to perform on these particular data warehouses, that too with the help of the OLAP. It navigates between various dimensions in multidimensional cube, making it effective and efficient reporting system. So there are several 5 to 6 operations that we will talk about, and we using those particular operations on the data on this particular OLAP. This particular data extraction is very much faster and will be very much efficient. Then comes the data and information. OLAP has calculation power for complex queries and data. It does data visualization using the graphs and other charts. And then there is the important prominent characteristic that it has is the OLAP cube. That is, it is having the multidimensional component. OLAP has multidimensional conceptual view and access of data to different users at different levels. The increasing number of dimensions and report generation performance of the OLAP system does not significantly degrade. So these are the 5 important characteristics that one can talk about whenever we consider the OLAP as the intermediate layer between the front-end data mining tool and the user. Then comes, this is the OLAP architecture. As you can see, this is a simple architecture wherein which here the data warehouse design we had already talked about. So with the introduction of this particular OLAP server tier, this is the special tier that is being going to introduce if at all we consider OLAP as the intermediate layer. And then you can see on the rightmost you have the client tier. That is, the users will be using some data mining tools, and then they wish to extract some meaningful patterns with the use of this OLAP server tier. This is one way to represent. And in the second way, you can see here directly from the data warehouse also the queries can be, the ad hoc queries can be extracted with the reporting interface that is there on the right side. Or else you can use the OLAP layer here. There are 2 ways of doing it. One is the data warehouse is directly connected to the ad hoc reporting, or else the tool itself. Otherwise, it is connected to the OLAP server, that is the intermediate layer, and then that particular OLAP layer is being connected to the user layer, or else you can call it as the presentation layer. This is the other way of architecture. And then the third way is, you can see here, wherein which the data warehouse is consisting of the data marts also. So it is not a centralized data warehouse itself. However, the centralized, or else you can call it as the enterprise data warehouse. So that particular enterprise data warehouse is being once again split into data marts, that is subject wise, inventory as one subject, sales as the other subject, and purchasing as the third subject. So here, once again, we are not directly connecting the OLAP layer directly to the data warehouse. However, the OLAP layer or else OLAP tier is directly connected to the data marts. So here, the introduction of the data marts directly connected to the OLAP server, or else you can call it as the OLAP tier, and then the other end you have the presentation layer. So these are the three types of architectures that one can visualize after the introduction of the OLAP tier. Then the prominent component that we were talking about is the data cube. What exactly is the data cube? This is the multidimensional data model that stores data in the form of a data cube in a data warehouse. So as you can visualize this particular data cube nearest to the rubric cube. So every kid will be playing with the rubric cube in order to arrange the same colors on each side. So just interpret that particular rubric cube just like a data cube, wherein which it is having a three-dimensional space. So here generally it's supposed two-dimensional or three-dimensional shapes, and it gives the data in order to view in different views and from the different perspectives. So here the main component that we are talking about is the dimensional component. So each and every query we can place with various dimensions. So here, in order to view, take the considerations of different views or as different perspectives, or else you can call from different dimensions, this particular data cube can be very much helpful. So this is the illustration of the data cube. This similarly looks like a rubric cube, you can see here. So it is having X, Y as well as the Z direction here. We are considering a three-dimensional cube. And here you can see on the X you have time mentioned, and then on the Y-axis you have product dimension, and in the third dimension Z is the location dimension. So each cell over here you can see I had bifurcate this particular thing in a gray color thing. Each and everything is called as a data cell. So on each side you can see there are 5 by 5, 25 data cells. And in between also there are things. So this particular three-dimensional thing is called as a data cube. So in this particular data cube, the whole data will be stored. Or else you can call in this particular data structure, the whole data will be stored under various dimensions. So this is another perspective of data cube looking into. Here you can see this is region A. So one axis you are considering the region. The other axis you are considering the quarter, first quarter, second quarter. For every month, every 3 months, we are considering it as a quarter of a year. So 4 quarters we had mentioned it on one axis, and then on the third axis we are mentioning the product as one of the dimensions. So this is another example with a different look of the same data cube. And the third example you can see here, this is just like a slicing kind of thing, wherein which it is conveying a different kind of look and feel. So here it is an example 3, and then in the example 2 you can see here along with the data you can visualize on the x-axis you have the time as the dimension, and on the y-axis you have the source, and on the z-axis you have the root. So each and every cell, if you consider this x and y, source and then time, you can see that to first half, second half. Once again, quarters are being quarterly is being mentioned over there. 4 quarters are being mentioned on x-axis, and then 6 sources. Or else you had split it into Eastern Hemisphere and then Western Hemisphere. So all these countries pertaining to Eastern Hemisphere like Africa, Asia, Australia, Europe are placed on the top of y-axis, and then 2 countries, North America and South America of Western Hemisphere, are being considered the lower part of the y-axis. So you can see this is the source, and then you can have the data. If you take the case of this particular data, so the South America, here it is having the 600, and then 600 first quarter, maybe in $1 billion or something like that, and then during 27 of 1999, February 27, 1999. Likewise, this particular example will give a good impression, so that along with this particular data, you can visualize the data cell as well as the data cube. So this is the star schema with corresponding data cube. So one side we are telling about the data cube as a data structure, and then on the other side if at all you wish to convert it into the form of a star schema, you can see here the product dimension is there, time dimension is there, and then the sales dimension is there, and here the store dimension is there. So here the sales, the thing that is existing in the center is the fact table with 3 dimensions. Sales fact table, that too we are considering the facts as variable costs, fixed costs, indirect sales, and then direct sales. So these are the facts that we are considering, and then this is the star schema, and here 3 dimensions are being considered. One dimension is with respect to the product, the second dimension is with respect to the time, and the third dimension is with respect to the store. So each and every dimension will have its own primary keys. Like you can see, product key is the primary key for the first dimension. Likewise, time dimension table, time key is the primary key, and in the store dimension, store key is the primary keys. In order to connect this particular dimension table to the fact table, we are once again writing the same keys in the fact table also. So it gives a kind of join kind of thing, where in which product key, time key, store key, along with the facts, that is fixed costs, variable costs, indirect sales, and then direct sales. So other than these particular keys on the dimensional table, you have the other attributes also, like the product name, category, department. Likewise, there are other attributes for the other dimensions also. So this particular product I am considering on the x-axis and then on the y-axis we are considering the time, and on the z-axis we are considering the store dimension. So suppose if shirts is the product, and then the time is January, and then place is Mumbai, and then 500 is the direct sales or indirect sales. So this particular figure, you can see we are mentioning 500 over here, that too for the shirts product for January, that too the location of Mumbai. So in this way, we can represent the star schema. We can convert the whole star schema into the kind of data cube with the data. So this is once again a big, larger kind of projection given over here. So pages is one particular, store dimension is there, product dimension is there, and then the time dimension is there. So month-wise time dimensions are given over here, and here the stations are placed like Delhi, Mumbai, Chennai, and Kolkata, and then the products are based over here, like maybe jackets, shirts, trousers. Likewise, the products are being placed over here. So in this way, the whole data structure will be, the data will be represented in the form of a data structure. The modeling technique is the star schema dimensional modeling technique, and once again the data structure that we are using is the data cube, or else you can call it as the OLAP cube. So why this particular OLAP cube is required? Why don't we directly take the conceptual view, that is the star schema, directly as consideration? So a relational database table is structured like it is a two-dimensional thing, wherein which it will be having a kind of table representation, and then you can visualize a spreadsheet, or else storing individual records in a two-dimensional row by column format. This is the table that we'll be considering whenever we consider the database or else relational database management system. However, the fact that we consider in the data warehouse is the intersection of two dimensions, a row and a column. This is not directly interpreted in the table itself. However, this is the intersection part, wherein which two dimensions, like each data fact in the database sits at the intersection of two dimensions, a row and the column, such as region and total sales is there. So the fact that we will be considering will be the intersection point of region and the total sales. So that is how directly we can't use the data table. However, there should be a different kind of multidimensional data structure, which is called as the data cube. And the other thing, the consideration why we have to have a OLAP cube is SQL and relational database reporting tools can certainly they are meant for querying, reporting on, and analyzing multidimensional data stored in tables, but performance is very much slow. Suppose if the dimensions are being increased over time, or else if the table size is vast, or else if we are joining more tables, If at all you are giving a complex query, then the mining will be very much difficult by placing simple SQL queries. So for that reason also we have to have a complicated data structure called as the OLAP cube. So this is where this particular OLAP comes into picture, and the OLAP cube extends the single table with additional layers. So here, as we are mentioning, in a table, in a simple RDBMS database table, there will be it is of two-dimensional, and here we are talking about the intersection points whenever we are considering the facts into consideration. So here, this particular additional layer it needs to be provided for each and every table, each by adding additional dimensions for consideration. So a table may be a single table may be having several layers. So the single table can be converted into several layers depending upon the dimensions or depending upon the facts that we are going to consider. For example, the top layer of the cube might organize sales by region. Additional layers could be country, state, province, city, and even specific store. So here, this particular top layer of the cube, as we are considering the sales, so it is having a kind of 3 dimensions, wherein which by region we can have 1 dimension, and then by country also we can have other dimension. Likewise, city also may be another consideration. Suppose if you wish to consider state as the dimension, that is also possible. So in theory, a cube can contain an infinite number of layers. Only in theory, n cube, we will call it as the n cube. However, in order to store in the OLAP, we will be considering only 2 or 3 dimensional as the things. So let us concentrate on some of the operations that can be performed on a OLAP cube or the data cube. There are 5 types of operations one can operate on a data cube. First one is the roll-up operation. Second one is the drill down operation, which is just opposite to the roll up, and then slice operation is possible, dice operation, and then the pivot operation. So in the roll up, it is nothing but it aggregates the data on a OLAP cube by moving up or moving down. So it is a kind of aggregation. Already this aggregation concept we had already studied in relational database management system. It is nothing but we are moving from down, we are moving up, aggregating something to top. So that particular aggregation part will be coming into picture whenever we talk about the roll-up, or else it can be on the opposite side also. For example, you could move up in the concept hierarchy of the location dimension by viewing each country's data rather than each city. So from cities, we are aggregating all the data into a country. So we are moving up. So in the hierarchy pattern, we are moving. That is called as the aggregated data with respect to the location. So we are not considering each and every city over here in the roll-up operation. However, we are clubbing all the data and then we are taking that particular dimension as the location dimension. However, we are considering the country as the dimension over here. So you can see the example placed on the slide. So here this is the data cube we are talking about. On the x-axis we have in stock, category is one particular thing, and then time dimension is placed on other axis, and on the third axis we have the stock. So stock as the dimension. So here you can see there are several appliances, home appliances, electronic appliances like mobiles, laptops, furniture, kitchen stores, whatever the case may be. There are several categories. However, in the roll-up operations, all these particular categories will be clubbed into a kind of one category called as home appliance category. That too we will be considering quarter-wise or else half-yearly wise. You can see in the roll-up operation, the whole categories, it is known as a kind of consolidation also, wherein which the whole operation summarizes the data along with the category dimension here. So we are not considering each and every category, mobile, laptop, furniture or something like that. We are clubbing all those things into a kind of application appliances or else appliances electronics here. And then we are considering the time as quarter 1, what is the sales, quarter 2, what is the sales, likewise, how much are in stock or else what amount we had gained. So all these things can be done by consolidating the whole appliances into one particular whole categories into one particular category called as home appliances electronics. And the second operation that can be performed is the drill down operation. This particular operation is quite opposite to the roll up operation, wherein which will be coming from the top to bottom. So suppose in the earlier case, what we had done is the location we are not considering the cities or the states. However, we had consolidated and we had made the component as the country as an example. Here, what we will do is we will start from the top and we will reach to the finer details. So the reverse example we can give it as from the country we can have the like data of each and every state or else each and every city. So this particular drill down operation converts less detailed data, that is the aggregated data, into more detailed data through one or two methods, that is moving down in the concept hierarchy or else adding a new dimensions to the cube. Suppose if the dimension called as state is not existing, then we will, and the data is available in the database or the data warehouse. So we can drill down or else we can consider that particular concept called as the city or the state, and then we can drill down by using this particular operation. For example, if you view sales data for an organization's calendar or fiscal quarter, you can drill down to see sales for each month moving down in the concept hierarchy of the time dimension. So this is the reverse operation, and we can see the example put on the slide. So one here, the same example I am using, and then you can see here in this particular figure, a multi-dimensional cube contains category of products and time. The time dimension has been expanded from quarter. So from quarter or else from 4 quarters that we are moving like month wise. You can see here instead of having the quarters in the earlier example, or else here you can see quarter 1, 2, 3, 4. Here what is happening is we had drilled down to certain level wherein which we are considering the months as a component. So here January, February, March, April, likewise 12 months are being considered instead of 4 quarters on the other side. So here this operation is called as the drill down operation. In this particular session, before ending in this particular session, we had focused on what is OLAP, how it is used, what is the necessity or else the need of having the OLAP tier, and then we had seen 3 types of OLAP architectures, and then coming towards the end we had seen the operations like the roll-up operation and then the drill down operation. Hope you had understood these particular concepts of today's session. If you have any queries, you can write to me, which is mca@ignou.ac.in, wherein which I will be answering your queries. With this, I conclude this particular session, and we'll be continuing in the next session with the other 3 operations on the OLAP cube. Thank you.